And my plan for today is as follows. I will start to talk a little bit about the examinations. After that, we're going to look at the quiz that you guys did for today. And the last part that I will talk about is an example. So we will do one example, and then after that, you guys can start working on the tasks from lecture 7. So examinations, quiz, an example, and then you guys can start working on the tasks on your own. But let's jump to the examinations, and let's start with examination 1, the one where you handed in your report and your code. And last week I got a question about how many students handed in for that examination, and I have now checked it. It was 247 solutions that was handed in, but it was 89 students who handed in one or more solutions. And that is roughly 63% of registered students in the course. So 89 students handed in for the first part of examination 1. And after having gone through all of them, I would say that generally I think you did really good on the examination. But I would like to repeat something that I mentioned last week, and that is that we must be structured. I will share my screen here with you guys. Give me a second. So I just picked one task at random here. It's the one with the travel company. And if we look at the instructions, it tells us what we should do. And it also tells us in what order that we should do stuff. So it tells us that we should start by analyzing the task using Polya's problem-solving technique. After that, we should write an analysis report, giving some template. And then it's time to write the script. And the final step is, of course, to upload it. But it seems like a lot of you guys skipped past the first 2 steps and jumped straight to step number 3, which is to create the script. And it led to some sad situations where I, as the teacher, had to fail you guys, some of you guys, for not analyzing the problem properly and deciding how to solve it, because you didn't solve it as it was required, or that you didn't upload the report, just uploaded an empty report or not according to the template or something. So do all the steps, and as I mentioned, the template or the report, if we take a look at it, I'll just scroll down here. We have instructions for how to fill out the report, and it is important that you follow them. For example, the instructions here tell us that we should remove any text in italic, and we will see that we have that on the first page where we replace it with the name of the task and your name, but also under each of the sub-chapters here. So you should remove the italic text, and then you should do the last steps here. Rephrase the problem, reflect on difficult words, and explain the plan. But before you delete the text, actually read it, as it will give you some instructions of what you should write here. And I will just want to mention one more thing here, and it's about devising the plan. We should do this before we write the code. So this chapter is your plan for how you will solve the task when you start writing the code. Meaning that in here, you shouldn't write the code and you shouldn't reflect on your own code, because when you do this step, you shouldn't have created your code yet. You do this before. So it's a flowchart or pseudocode, or sometimes it might be good to, for example, draw a picture. We had that with the labyrinth, for example. There it's perfect to draw a picture of how you represent the labyrinth, for example. So just remember that, that do the steps in order from the instructions here. And I will be a bit more thorough when I check it for your next hand-in, the second part of examination 1. So please be a bit more careful and thorough. And we have also had deadline for the second examination, the one where you give peer review or critical review. And I hope you found it interesting to look at each other's code. In some cases, it might even have been harder to read someone else's code than to actually write your own solution. Because it is tricky to read someone else's code when you don't know how they was thinking about solving the problem. Or maybe you got an aha moment when you saw how someone else solved the same problem as you did. Aha, you can solve it in this way. That was clever. It was fun to see that you gave so much feedback. And when I did a quick count, I got it to 98 students who both uploaded one of their own tasks and gave feedback to 2 other students. So roughly 100 did that. But then there was also a few students who missed one of the parts, either uploading or giving feedback, or who choose to not do it now and are waiting for the re-examination. So there were a few more students who did either upload or gave feedback, but didn't do both of them. But you can do that. If you missed it, you can do it at the re-examinations later. If you can get negative feedback for your report, well, you can get from your peers when you're doing the peer review, but if there is something negative about it, something in particular that I want to comment on, I write it in code grade, so then you can read it in there. And there was also a question about when it will be graded. So the first part of examination 1 is already graded, and for the second examination, it will be graded shortly. So within a few days, I would imagine that I can get through it. But leaving the examinations for now and jumping to the quiz that you have been working with for today. And when I looked at it, it was 84 students who choose to do the quiz, and that is roughly 59% of registered students. And you got an average of 84% correct answers. So a little bit fewer who did it this week, but I think the percentage for correct answers or average correct answers is still good. And there were some of the questions that I would like to talk about this week. All right, so this is one of the questions, question number 3. And for this one, you should fill in the mode and how you read the first name and the last name, and then the last one here is that you close the file too. But here for B and C, there were quite a few of you who answered read. And we cannot use read here because if we look at the code, we will see what happens if we use read here is that all the content of the file will be stored in first name. So not just the first name, but all the content of the file. And then last name will have no content. So that is why we cannot use read here. And we don't specify anything here that we should only read a few characters or something. So the default is to read the complete file, all the content of the file. That would be stored in first name. So that is why read doesn't work here, and you have to use readline instead. And there is actually one more question that I would like to show you guys. And if we do this instead, if I share my desktop with you, now you guys can see my desktop, right? Yes. So yep, cool. Thank you. And if we look at task number 4, you had this bit of code that you had to fill out, and it was names file and in and names file. I think you should fill out. And here we have to be a little bit careful because we can't use any name given, because we can see here that in the code that was given, the name is already used. So we have to use names file here and here. So we can't make up something like in file or something. And then we had to fill out in. But there is actually a problem with this task. The problem doesn't affect the answers that you should give, but there was one of you who found the problem. So I thought it was fun to bring it up and show it to you guys, because it said that we should print all the lines from the file. And here I have a file with some names in it. But if we run this, we see that it only prints 2 names. So there is a problem. It should have printed 4. And the problem is this line here. The example should have looked like this. If we run it now, we can see that it prints all 4 names. Given that it also prints the new line, but it at least prints 4 names. And what we're doing here, and how it was in the example or in the quiz, was that we are reading 1 extra line each time. So we are not printing every line, we are printing every other line. So it was just fun to bring it up, as there was one of you guys who found this. So I'm very thankful to the person who found it and pointed it out. I will, of course, fix this for the next iteration. All right. That about the quiz. We will see a little bit more about the syntax that was also from the quiz in the example that I will do in just a minute. But first, there is one thing that I want to bring up, and that is that we are now a few weeks into the course, and we have had the first part of examination 1, and it's soon time for the second part of examination 1. And the second part will contain functions that we covered last week. It will contain file handling and exception handling or error handling that we're covering this week. And it also contains lists, which we will cover next week. But these topics are trickier than what we did the first couple of weeks. So it's a step up when it comes to difficulty, and I just want to make you guys aware of that, and I would really recommend you spend the time required to understand each topic. So put in the hours to understand the topics, read the book, do the tasks from the lecture and exercise. It's not about finishing as quick as possible. Don't skip any tasks because, as I said, it's not about finishing as quick as possible. It is about learning the topics. And it's easy to fall behind or slip behind if you don't work continuously. And if you do fall behind, it can be tricky to catch up as we're trying to cover new stuff all the time. So do yourself a favor and put in the time required to learn these topics, especially as I said, they are a little bit trickier than what we did the first couple of weeks. All right, let's see here if we can continue with an example if there isn't any questions right now. All right, let me see if I can share the task with you guys. Here we go. So this is the task that I was thinking that we should work on today. And I'll give you a second to read it and then we'll go over it together. All right, so we have the task description on the left here where it says that we have a few developers who have an ongoing competition to see who introduces the least number of bugs into their code. And they store the current standing for number of bugs that they have introduced in a text file, and we can see the current content of the text file on the right hand side. So we have each developer and how many bugs they have introduced. So Anna has 5, Kalle has 7, and Max has 6 bugs currently. And our task is to create a script that can read this information from the text file and display it to the screen. So that is what we are gonna try to do. And my plan is to do it this way. That we will first open the file and then we will check if there are more developers, and if there is, then we will read the name of the developer, how many bugs they have introduced, and then we will print that information. And we will continue looping around here as long as there are more developers. And when there are no more developers, we close the file and we're done. So basically, open the file, and for all the developers, read from the file their name and the bugs, print it to the screen, and then when we have done that in a loop, we're done and we close the file. All right, so that's what we're going to do. We have a plan for how to do it. So let's see if we can do it. All right. So what should we do to solve this? The first we need is that we do need a file which contains the developers. So I will create a file and I'll name it bugs.txt. I'll save it on my desktop. That works fine. And we'll add Anna. She had 5 bugs. Kalle had 7 bugs, and I think we had Max who had 6 bugs. So we have our text file, and next let's create a script, and I'll name it something. Main.py works fine. So let's see if we can come up with a solution for how to do it. We had a plan for how to do it. We have developed that. So let's see if we can follow our plan. The first thing we said that we should do was to open the file. So I'll do that. And we specify the path to where it is. And I know that I saved it on my desktop and I named it bugs.txt. And the mode of the file that we're going to read is, or we are going to read it, so the mode is R for read. The next thing that I had in my plan was to, for each developer, I should read their name and the number of bugs and to print it to the screen. And the way I will do it is how they did it in the book. So I will start by reading the name of the first developer. So I'll say name is equal to the bugs file, and we have read line. And I will also make sure to strip out the new line that we have in the end of the line that we read. So I get rid of that. And now that I have the name of the first developer, I can create the loop to go over all the developers. So it would look something like this. I will write it first and then we can take a look at the code together. I think we will separate them a little bit. So we have the loop here. So we read the name, as we said, from the file, the first developer's name. Then we say continue as long as name is not empty. And we know that when there are no more lines in the file, it will return empty. So it will continue as long as we can read something from the file. And then we continue to read a number of bugs that the developer have introduced. Then we print that information to the screen. And then we end the loop by reading the name of the next developer, or empty if there are no more developers, and then we loop around. So here we have our loop for reading all the developers, names and bug count, and printing it to the screen. And there is one more thing that we must not forget to do, and that is to close the file. And let's just clean this up so that we don't have lines with spaces on them. And if we now have created a main function, we must make sure that we call it. So we say that, all right, if we start this script and not import it, we want to call the main function. All right, let's see if I manage to write the code correct. So what happens if we run it? And we see that it prints that Anna has 5 bugs, and Kalle has introduced 7, and Max 6 bugs. So we managed to get it correct, and we did it according to our plan. I'll just double check the chat and see what's going on. All right, I see Niklas has answered. Nice. And so now we have solved the task that we should solve. But I was thinking that we could continue working with this example a little bit. As we have the code here, let's continue looking at it for a bit here. And the first thing that we will see, if I misspell the name here, for example, and then I run it, our script will crash. And the same goes if I, for example, instead of saying that Max has 6 bugs, I write 6 with letters. And then if we try to run it again, we see the same thing happens, that the script crashes. And in this case, it's here when we're trying to read a number and convert it to an integer. It cannot do that because we write it as the word 6 instead of using the number 6. So let's see if we can fix this by introducing some exception handling or some error handling into our script, because it's always nice if we as developers can gracefully handle any errors that occur in our code. It might be that we decide after an error has occurred that we want to stop running, we want to finish the script. But it might be in other cases that we handle it gracefully so that we can ask the user again for some information. But in this case, we will add some exception handling, and I will write it first, and then we can take a look at it and see how it looks. So we can see here that I have added a try except, and I will catch file not found errors and give an appropriate error message for that, and also value errors, so that if we try to input 6 with letters instead, it will tell us that it must be integer numbers. So if we try it again, so we misspell the file name, we can see that now we get our error text instead. So we gracefully catch it and give some information to the user. And it also catches if we in here say that Max has 6 bugs, and we try to run it now. We can see that, all right, when the error happens, it gives us the error message, and then we can go in and fix that and put it back to 6 and run it again to see that now it works. So we can handle errors gracefully, but there is another problem here that I want to bring up, and that is what happens in the case that we change it in here to 6, as we had a second ago, and we run the code, and when we are in here, we try to convert that number to an integer, and we fail. Well, we jump from here down to one of the excepts, and it checks, is it a file not found error? No, it's not. It's a value error. So we jump from this line right down here and prints this message. But that gives us a problem because then we never closes the file. So we have to somehow take care of that. That it shouldn't matter if everything works as it should, or if there is an exception. We should always close the resource that we have opened. And we can do that by moving it, the closing of the file, to a finally block, and just have it down there instead. So if we put it down here, so it looks like this. Now, independent on if there is some exception raised here in our try block or not, we will always close the file. And we can just make sure that it still runs, that we didn't mess up the syntax somehow. And I see that there is a question about default error messages. Yes, we can mention that, absolutely. Give me a second, I'll just see if there's anything else. We'll take one thing at a time. So the default error messages, we can add a clause here to say except is it 1 or 2 R's occurred? Let's have it like this. We can have a default one. So if something goes wrong in here, there is an exception in here, something goes wrong, what will happen now is that Python will check, all right, the thing that went wrong, was it that the file was not found? Was it a value error? And if it wasn't one of these, it will go to the except that we have added now, which doesn't specify an error. So if we don't specify an error, it will catch all other errors that is not explicitly specified. So we can use this to catch anything that we didn't think about. So maybe when we add some more code in here, maybe we could have another exception in here, and then we would catch that here. When we write try excepts, we try to be as specific as possible to always specify what type of exceptions that happen. So normally we leave this part out, but we can have it in here just to say the default one. And I see that there's a question about do-while loops, and we don't have the do-while loops in Python, but in, for example, all right, yeah, so Niklas beat me to it. Thank you, Niklas. All right, and Niklas, just let me know if there was any other questions I missed.
I think you covered the messages or the questions. Yeah.
Good. Thank you. So we moved it to finally, just to make sure that we always hand back the resource to the operating system, or so that we are not holding any resources that we don't need to hold. But closing the file, it can sometimes be hard to remember to do, because we are focused on reading the information from the file and doing something with that content that we read. So it's easy to forget, but luckily for us, there is a way we can fix this, and they don't mention it in the book, but we can use something called context managers. And we can use that for files. So I will rewrite this example that we have here using a context manager to show you how that would look. So just give me a second here, and I will rewrite the code just a little bit. And if we try to run it, just to see that I didn't mess anything up while changing it, we can see that it still works as it should. So what did I do here? Well, I removed closing of the file, because if we use a context manager, the line that I added here, that will be done automatically for us. So we can say with open this file and as a bug file. So open the file and call it bugs file. And then within this block of code here, I can use a bugs file. It will be opened for me, and I can use it in here. And as soon as we leave this block of code, the file will be closed automatically by Python. And it's quite handy syntax, as it becomes a little bit cleaner, and we don't have to remember to close the file. It's done automatically for us. So context manager, it's called. We can use it, for example, when we are working with files, but we can also use it in other cases, like if we are accessing a database, or in other cases. But we can use it here. So I just thought that I would show it to you guys. And we will also continue with this example a little bit, just for a little bit more, because if we have this file where we store the number of bugs that the developers have introduced, wouldn't it be nice if we could update that file from the script. So that is the next thing that we're going to do. But before I do that, I will move the code that we have in main to its separate function. So I will just create a function for it just so that we can separate the code a little bit. So I just move the code from the main function up to read records. And as always, let's try it to see that I didn't mess anything up. No, it seems like everything went well so far. So let's see if we can create a new function that updates the file and update the number of bugs that one developer had introduced or has introduced. So we need a new function. And I'll call it increase count. And we will need to supply the name of the developer for the developer who have introduced a new bug. So we need to do that. But if we're going to do this, my approach is going to be as follows. I'm going to read from the file that we have, the original file, each developer and the number of bugs that they have introduced. Then I will write it to a temporary file. And when I find the developer that have introduced one new bug, I will update the value for that developer before I write it to the temporary file. And then we do this for all the developers. So in the end, we will have the original file and an updated temporary file where we have the updated value. And after that, I will delete the original file and rename our temporary file to the same name as the original file, which means that we overwrite it with the new data. So that is how I plan to approach this. And to do that, we need to open two files, one for reading and one for writing. And I'll use this context manager that we just saw. And let me just write a little bit of code here. So we can see here that I have said it, all right, first open the temporary file for writing, and then I open another file, which is our bugs files for reading. So we are reading from the bugs files and we're writing to the temp file. And after that, it is similar or a little bit similar to the code that we had up here. So I will copy that and modify it. And then after that, we can talk about it. So give me a few seconds to modify the code here. All right, let's take a look. So we open the files, both of them. After that, if we compare to what we had before, we still do the same looping here where we first read the name of the first developer, and as long as there are more developers, we continue looping here. And we need to read the number of bugs that developer has introduced. And if the name that we have read is the same as the one that we want to update, we increase that count by 1. And then let's see here. We will have to do this later. Let me just move this one. Otherwise, we will get a problem. Because what I want to do next is that I want to write the name of the developer and how many bugs they have introduced to the temporary file. And after that, in the end of the loop, I want to read the name of the next developer. So I want to write it to the text file, to the temp file first, because otherwise I would read the name of the next developer before writing it to the temporary file. So here we have a loop reading all the developers and increasing it for one of them and then writing it to a temporary file. And let's see, the next step, what we need to do is that when we have done all of this, and it's then the two files are closed automatically by Python, there is one more thing we need to do, and that is the thing where I said that, all right, we delete the original file and then we rename the temporary file. So that would look like this. But to do that, we must import IO. So we import the IO module, or OS module, sorry, OS module. So we import this module OS so that we down here can do os.remove, and then we specify the file that we want to remove. The temporary file to the name of the original file. All right, interesting. Are there any questions, Niklas?
Yeah, I mean, I think I've answered them all. I was just a little bit not 100% sure here, but I think I am regarding the lines 21 and 22. If you just switch them, so you open the other context manager within the other one, it shouldn't matter, right?
No, it doesn't matter
because
in what order you do it, as long as you do both of them.
Yeah, exactly, because it's no iteration or anything. So
no.
Which is, yeah.
All right, cool. All right, we've written a lot of code. Let's see what happens if we run it. At the moment, nothing would happen as we haven't called this function yet, but let's try to call it. Increase count, and let's update for Anna, for example. And if we try to run it, we see that Anna has 6 bugs, and what if we run it again? We see that she now has 7 bugs. 8 bugs. So we can increase the number of bugs that one developer has using our increase count function. And just to iterate, what we did here in this one was that we opened 2 files on these lines here, and it doesn't matter in which order we do it, as long as we open both of them. We open one for writing and one for reading. Then we have the same construct as we had before, where we have a loop looping over all of our developers, reading their name and introduce number of introduced bugs. But we added an if statement saying that, all right, if it is the developer we're looking for, we increase the number of bugs by 1. Then instead of printing it to the screen, we are writing it to a file, our temporary file. And then we loop around here. And after we have written all the developers to the temporary file, we remove the original file and rename the temporary file to the same name as the original file had. So for anyone looking at the file, it would look like we have updated that file. All right. I think as we talked about these 2 lines here and what order we should use them, we can make one more change before we end this section here with the examples. So we see here, if we look at the script that I have here now, we see that we have the path to the 2 files here. We have it here, 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 We have it 2 times here, and we also have it up here. So we have written the path to the file in several places. And I tried to be careful so I didn't do any misspelling or anything, but it can easily happen that we misspell it. So maybe a better solution would be to create 2 constants for the names of the files and use those instead. And it could look something like this. This time I copy it so I don't have to write it again. So we see that we have created 2 constants. We have given them names using uppercase letters, and we have specified that, all right, bugs files is in this location and the temp file is in this location. Now, instead of each time writing the full path, I can use these 2 constants. So I can change it up here where we read it. I can change it down here. So we had the temporary file here, temporary file, and here we have the bugs file, and we use them down here too when we did the deleting and renaming. So let's see if we can delete the bugs file, and we rename the temp file to bugs file. And before we talk more about it, now that we have made this change, let's try to run it and see that everything works as it should. And yeah, it still works. So we didn't introduce a bug or something. And by looking at the code, it becomes a little bit easier to read as we don't have these long paths here. And another benefit would be that if I decide to rename the files, I can do it in one place up here, and then it will take effect throughout the script. So we can use constants for this, but there is one more thing that we can do to make it a little bit easier to read now that we have shorter open statements here. And we can actually do these 2 on the same line instead. So we can have several opens in one line, and we just have to remove one indentation level here. So if we run it again, we see that, all right, it's still working as it should, but now we have this context manager handling both our files. We have it on the same line here, which makes it a little bit easier to read because we have fewer indentation levels. So we got rid of one indentation level by doing that. So we just refactored the code a little bit to make it a little bit more readable, or hopefully a little bit more readable. I think it's a little bit more readable at least. But let's see. Okay, I see that you have answered some questions. I think I will stop sharing, and then what we will do is that we will stop the recording here,